how do you explain the fact that the first ionization enthalpy of sodium is lower than that of magnesium, but its second ionization energy is higher than that of magnesium? Okay. Now, if I make Na to Na plus, this is IE1, and Mg to Mg plus electron, this is IE1 for magnesium. Now, IE1 for magnesium is higher than IE1 of sodium. Yes, indeed. Why? See, although there is a pain, you're removing electrons, so which is not very nice. You're dropping electron away. That means you have to supply some energy called ionization energy, no doubt. But please note, sodium has a relief. After removal of electron, sodium gets a noble gas configuration. So after the removal of first electron, sodium attains noble gas configuration. So sodium lets this electron go relatively more easily. Magnesium does not gain any benefit of noble gas configuration, and not just that, sodium's nucleus has 11 protons while magnesium has 12. 12 protons attract the electrons more strongly in magnesium as compared to 11 protons in sodium. And because of these reasons, magnesium finds it difficult to let the electron go, and that is why it has higher first ionization energy as compared to sodium. This is explainable, fine. Now the second part. But its second I is higher than that of magnesium. Now let us see what happens when Na plus is going to Na2 plus. Na plus has a noble gas configuration, which is actually a very stable configuration. Now, the moment you want Na2 plus gas, you are trying to break noble gas configuration, which is really heartbreaking. You know, it's a very difficult thing to do anyways. You cannot break away noble gas configuration very easily. So, IE2 of sodium is expected to be very, very high, and indeed it is. On the other hand, if you have Mg plus and you are taking away one more electrons making Mg2 plus. Now, magnesium 2 plus actually it has attained noble gas configuration. This has noble gas configuration, which is very easy now. So, whenever any ion or atom attains noble gas configuration, it is more stable, right? So, when magnesium loses electrons to form Mg2 plus, there is some solace, some happiness that at least I have noble gas configuration, so it gives away electron relatively more easily. In this case, it is the worst. You are snatching away electron, which is bad, and not just that, you're also breaking noble gas configuration, which is doubly, triply bad. So that is why IE2 of sodium is way higher. IE2 of sodium is going to be much, much higher than IE2 of magnesium, because in one case, you are making the noble gas configuration. In the case of sodium, you are breaking the noble gas electronic configuration, which is very stable.